Yeah, good evening everyone. This is P. Srinivasabhai. So now I'm gonna explain a case study relating to the dataset of cardio fitness product, and this will give an idea of linear regression and the prediction and how the predictions are done by a machine learning model. So the dataset I chosen is the cardio fitness product, and the target variable here is the miles. Here is the problem statement. Which variables are significant in predicting the number of miles walked? So there are total nine features, of which miles is a target variable. So the rest eight features like product, age, gender, education, marital status, etc. are how will these affect the number of miles walked is the problem statement. So let's start with the analysis of data set. So my data set consists of total 180 instances, which means there are total 180 details, and the eight features as described below, and of which three are categorical and five are numerical data. This is all about the data set, and let's move into the exploratory data analysis. Exploratory data analysis, this is nothing but the data visualization. How does the raw data look in terms of graphs? So let me explain this thing. Let me explain the first graph. This is the distribution of usage of the cardio product, uh, rated from 1 to 7. Uh, the rating is high in the range of 3 to 4. So many people are rated in 3 and 4. The frequency is high of almost 70 and of almost 50 to 55 in for the rating of 4. So now another, this is a scatter plot of income versus product and miles. There are three different products in this cardio machine, and we can clearly see that the third cardio machine is slightly costlier than the first two. And also if we see the dots, the color of dots which is mentioned, color of dots gives the info about the miles, number of miles. So as you see here, from 0 to 150, the shades of blue represent 0 to 150 miles, of which the first two products are similar to. And from 150 to the rest 350, they are they're high, and also they're only shown for the product 3, because we can so with this we can say that number of the high income people tend to do more exercise, and that too in a costlier machine. And then this is the distribution of product. Number of males do more exercise than females, is which is clearly visible here. Almost more than 100 people, 100 male do the exercise, and female up to 78, 79 people, 79 female. And the rating of fitness is also given here, which is also a factor that affects the number of miles walked, which is a target variable. So I mentioned here, there are no outliers and missing values based on the scatter plots observed and the data set observed. Now let's go to the ranking of the data set. So now to predict the to design a machine learning model, we have to find the mostly correlated features. I have found out. I have taken the top four correlated correlation features, which are product, fitness, age, and usage. So these are the mostly relatable variables. So I have taken the analysis EDA of these three: usage, fitness, and product. So as you have chosen these four columns, the rest four columns will be automatically uh, kept aside for the evaluation. I mean, by the machine to analyze the things. So this is our final machine learning model of 180 instances and four features which are to be compared. Now this 180 features are divided into a 70% and a 30% two data sets. The 70% data set is called as a training data set, of which the machine learns about how the product, fitness, age, and usage, the four factors, are affecting the miles. So this is the training data set. The machine learns from this training data set, and now and now coming to this testing data set of 30%, which is 54 instances. These these are these are the final value of the testing data. This is not known for the machine, and it will be predicted. So the predicted outcome is 82.0.8828, which this is the R square value, which is also similar to the percentage. So the prediction of a model is 82.8%. So this is pretty accurate. This is pretty good accuracy, and if we test this on the complete data set, we are getting an accuracy of 84%, which is a very good accuracy. And we can consider this model for the further usage, because the accuracy is more than 75%. So we can consider this data set, sorry, this machine learning model for the usage. And this is my infograph and case study. Thank you.